Welcome to qnawire.
The problem is, suppose that if this third derivative of f is continuous, and the derivative and second derivative at the point c is equal to 0, but third derivative c is greater than 0. Does f has a local maximum or minimum at c? Does f has a point of inflection at c? So first, for this question, the answer is not necessarily. The counterexample is if f of x is equal to x cubed, at the point x equal to 0, if c is equal to 0, we have f prime c is equal to f prime 0, which is equal to 3 times 0 squared, which is equal to 0. And second derivative at c is also 0, but the third derivative is equal to 6, which is positive. But the function f of x has no local maximum or minimum value at the point x equal to 0. For the second question, the answer is yes. The reason is, since the third derivative of f is continuous, and the third derivative at c is greater than 0, so we have there exists an interval x1 to x2 such that c belongs to x1, x2, and f of x is greater than 0 for any x belongs to this interval x1 to x2. So this is third derivative. So we have the second derivative is increasing on the interval x1 to x2. Since c belongs to this interval and the second derivative at c is equal to 0, so we have f prime x is less than 0 when x belongs to x1 to c, and the second derivative x is greater than 0 when x belongs to c to x2. So the second derivative changes signs at c. So f has a point of inflection at c.